everybody. We're going to refocus on greatest common factor. And we talked in class that greatest means the highest or the biggest. Common is something that they share or they have alike. And of course, factor are numbers that are multiplied to make a product. So we're really breaking down a number into its factors. So we're going to first take a look here. We've got find the greatest common factor of 12 and 18. We first start by listing factor pairs in order. It helps us see to make sure that we have all the factors. And we always start by 1 times a number. Then we check to see which factors they have in common. And then we'll go through and we'll find out which one is the greatest or the biggest or the highest. So we're going to go ahead and start with listing out the numbers 12 and 18. And I always start with 1. So 1 set of 12. Then we use our divisibility rules. 2. 2, yes, 2 will work because 12 is an even number. 2 times 6. 3 is a factor of 12. 3 times 4. Now, as soon as you get that you've got 2 numbers that are consecutive, 3 times 4, and we worked in our counting number order, we've got it all wrapped up. Smile, we're done with number 12. Let's move on to 18. Of course, we start with 1, so we have 1 set of 18. 18 is even, so we're going to do 2 times 9. 18 is divisible by 3, so we're using our counting numbers 1, 2, 3, and we have 3 times 6. The next number we're going to check with our counting numbers would be 4. 18 is not evenly divisible by 4. The one after that to check would be 5. 18 is not divisible by 5. That brings us back to 6. And since 6 is already paired with the factor of 3, we are all set. We've got 18, all the factors of 18. So there's listing out the factors. The next is finding what do they have in common. Well, they each have a 1, they each have a 2, they each have a 3, and they each have a 6. So now, of those common factors, what is the greatest? The greatest common factor would be that 6 that they both have in common. So the other way to do the same thing is prime factorization. So I'm going to go ahead and set it up and show you what it looks like with prime factorization. So we're going to use factor trees. We're going to start with 12 and 18. And with 12, we're going to factor out 12. I'm going to say 12 is, 6 times 2. We can use any of the factors that are in the factor pairs. So 2 is prime, so I'm going to circle the prime, but I'm going to still have to factor out 6. And I have 2 times 3 to make 6. So I've ended with all primes. There's nothing else to factor out. So 12 is equal to 2 times 2 times 3. I like to write the numbers in numerical order when I'm done. Now I'm going to do the same thing with 18. I'm going to factor out 18, and I can use any of the factor pairs that we have listed over here for 18. It's silly to do 1 times 18 because that doesn't factor it out, but I'm going to go ahead and I'm going to do 2 times 9. So 2 sets of 9. 2 is a prime number, so I'm going to circle it. 9 is not, so I'm going to factor out 9, and that's going to be 3 times 3. So if I do 3 times 3, now I have nothing but primes, times. So I'm going to rewrite my 18 as a product of primes is the same as 2 times 3 times 3. Now here's where this comes in. This didn't take long to do it when we listed our factor pairs, but here, what I have in common, 12 has a prime number 2, and 12 has a 3, and 18 also has a 3. So now we're looking at what 12 and 18 have in common. They have the prime 2, they have the prime 3. So we can take those prime numbers that they have in common. 2 times 3 equals 6. The greatest common factor is 6. And you can find it that way by using factor trees. So that wasn't so hard using 12 and 18, but what if we had different numbers? So let's say that we did this problem and we had, we're going to skip to a different problem. Let's go skiing. So we're going to do it both ways. I'm going to show you what it looks like if we did the factor pairs for 60 and 48. So we start with 1. We know we have 1 times 60. It's an even number, so my divisibility rules tell me I can use two sets of 30. Then we move on to the next counting number 3. We can get 3 sets of 20 to make 60. It's even, so 4 will work, and I know my 15s because of telling time, 15, 30, 45, 60. So 4 sets of 15. It ends in a 0, so 5 works, 5 sets of 12. And my next number is 6. If 2 and 3 work, 6 will work, 6 sets of 10. The only other numbers to check would be 7. No, 7's not evenly divisible into 60. Neither is 8. Neither is 9. So we're all done. We're going to smile. We've got that one wrapped up. Let's go ahead and work on 48. So factors of 48, we have one set of 48, always starting with 1. It's an even number, so we can do 2 times 24. 4 plus 8 is 12. If 12 is divisible by 3, then 48 is. We have 3 sets of 16. It's 4 sets of 12. 5 doesn't work. 6 does, though. 6 times 8 makes 48. And the only other number we have to check now is 7. And 7 times 7 is 49, not 48. 8's right there as a pair with 6, so it's all matched up. We're all set. So they have quite a few numbers in common, but the greatest number that they have in common is 12. So even though they had 6 in common and they have 4, 3, 2, and 1 in common, 12 is the greatest factor that they have in common. So we can see that their greatest common factor is 12. So to go back up to see what the question was asking us, it wanted to know the greatest number of identical kits that they can prepare using all of the hand warmers and foot warmers. Well, they can make 12 kits. And we're not done answering the question. They want to know how many hand warmers are going to be in those kits and how many foot warmers are going to be in those kits. Well, the hand warmers were the 60. This is hand warmers. So if I go back here, my factor pairing with the 12 is 5. So there were 5 sets of hand warmers in there. And it said that there were 48 foot warmers. So when I find my 12, my pair that's hooked up with 12 is 4. So we have 4 packets of foot warmers in each of those kits. Now, that took a while. I want to show you what it's like with prime factorization. So if we did the same problem using prime factors or using a prime factor tree, we'd start out with 60 and factor it down. I'm going to say 6 times 10. I can use any factors. 6 is not a prime, so I'm going to factor that down to 2 times 3. 2 is a prime, and so is 3. 10 is not prime, but I can make 2 times 5. 2 is prime, and so is 5, so I'm all done. So I can rewrite that. I like to rewrite it in the order that they're listed. So 60 is equal to 2 times 2 times 3 times 5. So let's do the same thing with 48 using our prime factor trees. So I'm going to factor out 48. I'm going to use 6 times 8. Again, 6, we already did it over here, is 2 times 3, and those are both primes. 8 is not a prime, but I can do 2 times 4. 2 is a prime, 4 is not, so I can factor that down to 2 times 2. Prime, prime. So I can rewrite 48 as a factor of primes as 2 times 2 times 2 times 2 times 3. So when we look at what they have in common to find the greatest common factor, there's a 2 that can match with that one. Here's another 2 that can match with that one. This one has a 3 that can match with that 3. So the ones that they have in common to find my greatest common factor, we can say we have a 2, another 2, and a 3 in common. 2 times 2 times 3 is 12. The greatest common factor is 12, and that's exactly what we got here. So I hope that helps you understand how to find greatest common factor using all the factors that a number has, as well as using factor trees and prime factorization. So best of luck, keep practicing, and make a difference.